we have another lightning talk waiting for you today. I know we've had lunch. I know we're feeling like sometimes, like the post-lunch, the energy dips. But for the next speaker, I want us to just make sure we pump that energy up again, because this speaker is also someone I've happened to hear speak multiple times on the conference circuit. They are awesome. They record videos on YouTube. They write for Smashing Magazine, DevToe, and their personal blog. But the thing that I love is the thing that they put in bold in their bio, because they like going to the gym, going hard, and playing with their kids. Let's give it up for Atila Fassina. There we go.
Yeah, that's not gonna work. So, how's it going, everyone? Almost time for coffee, but yeah, before that, let's talk a little bit about reactivity. We're gonna dissect reactivity in 15 minutes. So what am I going to do? Am I going to speak like really fast and then you're going to get everything, and then when you get home you're going to parse everything, and then tomorrow you're going to wake up and you know everything? Yeah, that's not going to work, right? So I'll have to omit a few details perhaps, so take everything I'm going to say with a grain of salt, find me out in the hallway and we can talk at a little bit more length as it goes. But we don't have that much time, so just get straight into it. First of all, this is the one thing I'm going to talk. We're in a React conference, and I'm going to talk about other frameworks. And I want to address this really early in this talk, is that it's not about a framework war. We're all here to learn from each other. And the different application and the different solutions that we're going to talk about, they're not here to trump each other down or to replace each other. It's important that we understand that everybody is going to do the best they can, and everybody is going to keep learning. Anyway, thanks. Anyway, who am I? So Nathaniel already said a little bit, and I'll try to say it in my own words as well, and where I come from. So essentially, I'm a DevRel engineer at a company called Crab Nebula, and I'm also a Google Dev expert. And because naming things is hard, I replace handlers every social network. So I made this little shortcuts from my website, so you can find me there if you have any questions, if you have any comments about the talk, or if you just want to chat, I'm always going to be there. So at Crab Nebula, we are the ones behind the Tauri framework. Has anybody heard about Tauri before? Yeah. Wow, lots of hands, amazing. Great, so Tauri is the framework for creating native applications. Why am I talking about this? We have the backend that's written in Rust, and that's a constant part in Tauri. But Tauri renders a web view, and then with the web view, you can bring every or any framework that you choose. You can use HTML and CSS. You can use Svelte. You can use React. You can even wrap full-stack applications, frameworks like Next.js and Remix. So because of that, I play around with a bunch of different frameworks, and that's where this talk's coming from. Let's talk about rendering things on the web. First thing, React came around with a bunch of very cool ideas, rendering UI as a function of the state. And then there's this thing that we heard a lot, I think. Everybody heard this? The vDOM exists because the DOM is slow. This is a little bit of an oversimplification of the facts, which the vDOM exists because removing and replacing things from the DOM can become slow. So what we do is we abstract the DOM, we batch the changes, and then we reconcile again. So with one very big sweep, we take everything out of the DOM and we put everything back. Let's look how it works. Like chances are all of you have seen this, the rendering model, reconciliation you might have heard of. So essentially, we have this root component that has these props. So if prop A's change, as you would expect, the children components that use the props A are going to re-render. But because of the way that vDOM works, there's no way of tracking which props are being used. So if the parent component is going to re-render, everything is going to get re-rendered. And I lost my connection. So everything is going to get re-rendered. So the entire tree gets re-rendered. And this is the render model that's inherent to the virtual DOM. And that's all of you are quite familiar with. But in my experience, this is where things get a little bit fuzzy and some people lose track of that. And I'm back. So when you have a context provider, and the context provider re-renders, everything in between does. So if you have a context provider in the root of your app, and you change something, a data that's being passed through that context, your entire app's going to re-render. And this is something that then can become a problem. So you're all thinking, yeah, but let's not forget about memoization, right? As a matter of fact, the React team is working on this compiler that's called React Forget. And React Forget is still an RFC, so it's not in production. It's not available for us to play around with it. But the idea behind it, as far as I can tell, is providing auto-memoization to your components. So what's going to do is identify which props are going to be used by each one of those components, and is going to define some little blocks of memoized branches of your tree. So then when the props A is going to change, only the pink branch is going to re-render. And when the props B change, only that little color that I don't know why. I think it's teal. I'm going to go with teal. And it's going to re-render. And then the other one, that's the green, is never going to re-render because it's not using any props. But talk's cheap, right? Let me show you a little bit. So we have a counter because that's what we do. We are developers and we make counters. There's a little issue with my thing. So right here, what we have like on the code side, I have this counter component. And I'm just doing something funny here with the colors and replacing color based on the instance. But essentially, I'm setting a state, and then I'm gonna be showing the state over here. So what I do is I create a state in my parent components, and I have different instances of this same component. What happens is that when I render, I'm console logging. OK, so the first instance, which is with the badass color, gets rendered, and then the second instance gets rendered. What happened if I update the state on instance number 2? And my thing is, it's too close. So yeah, 1 second. I'm on the solid one. So sorry, a little bit of spoiler in this case. My thing just got like completely busted with the change of resolution. Yeah, here we go. So this is the React one. So what happens now if I render? So everything renders twice. Don't get upset about that. That happens on development mode. React renders each component twice, so you can make sure that every rendering is atomic. So what goes is they render twice, only in development mode. If we're production, it wouldn't. But then if I update the counter, everything renders again, regardless of which counter I'm doing. Let me clean it up. Counter number 1, 2 re-rendered, and so on. But then, yeah, we're talking about memo, right? And this is solid code. We're talking about memo, right? So let's go back. And what I'm going to do is then memoize my component. So what I'm going to do is const mCounter is going to be the memo version of my counter. And right here, I'll just make the second instance being memoized. Back, re-render. Everything renders twice on the first go. I'm going to go again I'm going to go now for my second instance, which is, no, I'm going to go to the first one. And only the first one re-renders because the second one is memoized. But what happens if I re-render the memoized now? Everything again. So memoizing is a solution when we want to avoid something from rendering, but it's not going to prevent everything because fundamentally, and something gone. OK, because it's still going to re-render more often. Because if I try to access the one that got rendered, if I try to access the one that's not memoized, it's going to re-render. Memoizing is made for big re-renderings. So if I have something that takes a lot of computation time, as Daniel mentioned in his talk earlier, he was memoizing even using signals. So because rendering is a very aggressive method, And some people started thinking that there would be a better way to describing those changes in the DOM. So some ideas came around to challenge the vDOM approach. And so the idea behind it is that we're going to render it once, and we're going to touch only what has changed. So let's check again the counter that I have for Solid.js now, which is a framework that's using signals. In this case, I need to bring back my solid code. This is React, no. And bear with me. The change of resolutions messed up my window setup. Here we are. Yeah, so on a first look, React and Solid look exactly the same. The difference is, instead of using state, we have this create signal, but I have the 2 instances of the counter, and the counter could actually be the same. We have the lifecycle method for the onRendered because I want to log when something is rendered, because things in Solid, they only render once. That means because signals can track only the changes that are only the changes in the data. So this means that the data is going to be able to notify the renderer that it has changed. Whenever there is a change in the data, there's going to be a tracker in the rendering, and then the rendering engine is going to change only, is going to touch only what's changed. So instead of removing the entire paragraph element, instead of removing the whole tree of the DOM, what's going to happen is that we're just going to update that value. So what does it mean? Everybody goes to Signal now and refactor your code? No, that's not the takeaway that I want for you to this thing. There is no free lunch. There is no like silver bullet. And Signals might have a good response to that on top of the vDOM, but it's important that we understand this too. So I'm going to dedicate a little bit of this time now to talk about the trade-offs of using signals. So the first one is a commandment. When you're using signals, it's you need to protect reactivity. You need to protect reactivity because it's delicate. There are a few things, if you're already familiar, if you're already seeing some comparisons between Solid and React, one thing that we do a lot is destructuring. Destructuring is when we get those props and we open it up in curly braces and we get all the keys of the object as a separate variable. We cannot do that because signals, we cannot track the changes in variables because they're stored as references. So therefore, we need to have a getter for the signals. Because we have getters for the signals, there is then a bunch of nice APIs that frameworks like Solid.js or Svelte have to help us protect reactivity. One of them is like iterating through lists. We have components like for and index that we need to use. We have control flow components like show or the switch match combo that's essentially using pattern matching. So those are all similar patterns that we have used. We have mapped through lists, through an array of lists. We have used ternary operators. Those are the same. The difference then is that here we need to have a little bit more caution when we're using those things because sometimes we need to memoize under the hood. But those cases are very easy to predict, and that's for the frameworks have those APIs for us. There's also like an on check when you need to explicitly say, oh, this prop, you may not be able to catch that on your auto tracking system, Mr. Renderer, but this is how it's going to happen. We have create effect for the side effects. And we have the create store if we're going to have like complex primitives like objects and arrays, and we want to have fine-grained reactivity on them. And we can batch some changes. But as a last thought, there is like different reactivity increments. So we don't need to go like all the way from vDOM to the other one to signals. We can use signals as different reasons. So when it all started, we have React with vDOM. Everybody thought vDOM was a great alternative, and everybody was using. But then this guy came up and said, yeah, remember Knockout.js? They came for very, very old. And I love signals. I love their application. And I want to talk to you a little bit about them. And then fast forward a little bit, like a few years perhaps, a lot of frameworks are actually adopting signals now in different reasons and in different ways of doing that. They have their own APIs that we're going to look in a little bit, and they have their own developer experience story. So for example, Vue, you have shallow ref, where you can store references, and Vue can track it for you. So you can update the values like that, essentially as you're doing a mutation. Quick has the use signal, where you declare a signal, and then you can either increment with a setter, and you can retrieve the value just like you would in a regular object. What Quick is doing, because it's a compiler, under the hood there's a getter there, but that's an implementation detail. Then we have Angular that's recently used signals. So Angular, you define it as a signal like this. You can set, so that's just going to change the value of the signal, or you can update the signal, so it gets as a parameter the previous value, and then it allows you to update that in a callback. And to access, you use the getter. Last one is Svelte with runes. It's not out yet. I think it's coming in Svelte 5, which should be released soon. But essentially, this is the API that they have. You define a signal with that $state thing, and then you create a getter, and you create a setter for the increment part. OK, so too long, didn't listen, or didn't read, or whatever. This is essentially how things are right now in the landscape of using of reactivity across different frameworks. And though signals might not be the best case for your team or something, there's definitely something there. So I would recommend you to have a look at them and see what's best there. And that's it for me. Thank you very much for having me, Brussels. See you at the coffee break.
Thank you, thank you.